A storm buried mountains while driving hurricane-force wind into Florida. But the March 1993 Superstorm never became a hurricane. It was extratropical, built around fronts and contrasting air. How could one circulation produce a coastal tempest on one side and an inland blizzard on the other? On March 12th, a disturbance moved from the Texas coast into the Gulf of Mexico. Then the pressure readings began to plunge. The center fell from about 1,004 millibars to 975 in less than 24 hours. Before the map could settle into one familiar kind of storm, Florida faced severe convection and coastal surge, while snow reached Alabama and the Florida Panhandle. That pressure fall is called explosive cyclogenesis, often shortened to bomb cyclone. The name describes the speed of the development, not a tropical transformation. Operational models underestimated how quickly and deeply the low would develop. Sparse observations over the Gulf also leave one limit on the record. Researchers cannot assign an exact share of the earliest pressure falls to the thunderstorms forming within the larger system. Across successive surface analyses, the disturbance became a closed and deepening low as it moved east over the Gulf. The falling numbers supplied the first discovery. This was no longer a weak disturbance drifting beside a front. The circulation and the frontal boundary were developing together. The faster the center deepened, the more urgent the next question became. What was driving the change above it? The pressure map raises the next question. What could remove air overhead fast enough to support such rapid deepening below? High above the Gulf, a deep bend in the polar jet reached south, while a strong streak in the subtropical jet crossed warmer water. The two currents phased. Air spread outward at high altitude, air below rose to replace it, and the surface circulation intensified along a strong boundary between warm and cold air. That boundary divided the developing cyclone into contrasting sectors. East and south of the low, the circulation drew warm, humid Gulf air northward. Behind the center, cold air wrapped south and east. The storm was not a uniform cloud covering half a continent. It was a moving arrangement that could place unstable warmth on one side and a frozen environment on the other. Florida radar supplied the first visible test. Ahead of the cold front, a long squall line crossed the state with embedded rotating thunderstorms. Damage surveys confirmed tornadoes, while records also documented waterspouts, destructive gusts, and coastal flooding. The warm sector was doing more than carrying rain. It was concentrating Gulf moisture inside a severe convective line. The radar line also turned the surface map into motion. Warm, moist air did not simply sit east of the low. It fed northward into storms advancing across Florida, while the cold front followed behind. The damage surveys then established that rotation inside the line had reached the ground. Each record added a different layer. The map located the sector, radar showed its organization, and surveys confirmed its consequence. Then the water measurement raised the stakes. In Taylor County, storm surge reached as high as 12 feet. That proved the coastal side could produce a hazard associated with hurricanes. Yet surge did not settle the storm's identity, because impact and structure answer different questions. The map still showed fronts, and a sharp temperature contrast wrapped around the low. The snowfall record revealed the other half of the circulation. Cold air behind the center met moisture being lifted by the storm. Snow fell as far south as Alabama and the Florida Panhandle, while the low moved northeast. The same Gulf that supplied humid air to the Florida squall line also supplied moisture that rose into a much colder environment inland. Newfound Gap, on the Tennessee and North Carolina border, received as much as 60 inches of snow. That measurement showed how deeply Gulf moisture had entered the frozen side of the storm. On Mount Mitchell, drifts reached 14 feet. Snow depth alone did not create those drifts. Strong wind within the broad circulation moved the accumulating snow and made the cold side visible as terrain changed beneath it. The snowfall map widened that discovery beyond two mountain stations. Heavy snow extended through the Appalachians and continued toward the Canadian border, while traces reached parts of Florida. The low was moving northeast, yet its cold side reached unusually far south. The map therefore answered where the blizzard existed, but it also opened a harder problem. How could the same circulation maintain severe convection on its warmer side? By March 13th and 14th, the low was tracking northeast and the evidence was climbing with it. Blizzard conditions extended from Alabama toward Maine. The snowfall map traced the cold sector through the Appalachians, while the pressure field and damaging wind spread farther north. Each record marked a new location, but the locations remained connected to the same moving center. The pattern had now produced coastal surge, tornadoes, immense snowfall, and blizzard conditions, but one station reading created the hardest test of all. At Mount Washington in New Hampshire, instruments recorded a gust of 144 miles per hour. That was well into hurricane force. If wind alone defined a hurricane, the argument would appear finished. Wind alone does not define one. A hurricane is organized around a tropical warm core. The superstorm was baroclinic, meaning it grew along a horizontal contrast between warm and cold air. Its fronts were part of the engine. The Mount Washington reading proved extraordinary intensity and reach, but it could not turn a frontal cyclone into a tropical one. That reversal changes the meaning of every earlier measurement. The Taylor County surge proves a hurricane-like coastal impact, not a hurricane classification. Florida radar proves severe convection inside the warm sector, not a tropical core. The newfound gap snow and Mount Mitchell drifts reveal the cold sector. The mountain gust shows that the circulation could reach hurricane force while preserving the structure of an extratropical storm. The human scale followed the same expanding map. More than 550,000 square miles were affected, placing nearly 120 million people in the storm's path. Nearly 10 million lost electricity. Every major airport on the East Coast closed at some point. Those consequences were not separate regional disasters, accidentally occurring together. They followed one circulation, connecting the Gulf Coast, the Appalachians, and New England. That chain of closures gave the storm's scale a practical shape. An airport in one region could close under snow, while another part of the same system was still tied to coastal wind and flooding. The point is not that every place received every hazard. The opposite is what made the event so revealing. Different places encountered different sectors, yet the expanding disruption followed one center moving along the East Coast. Now return to the surface map. Lines of equal pressure surrounded the deep center. Warm moisture streamed north on one side, while cold air curled behind it. Above both, the phased jets supported rising motion and rapid development. The map joins the pressure fall, radar line, snowfall field, and wind reading without asking any one measurement to explain the entire storm. If hidden weather physics changes how you read a storm map, subscribe to Eyewall Stories. The strongest clue is often the structure connecting hazards that seem unrelated. The final record pulls even farther back. Satellite imagery showed the storm's cloud shield stretching across much of the eastern United States, with the circulation spanning an enormous range of weather beneath it. Florida's convective line belonged to the warm side. The inland blizzard belonged to the cold side. The wind field turned around the same deep center. This is why the title describes impact rather than a literal transformation. The cyclone did not become falling snow, and it did not acquire a tropical warm core. It organized blizzard conditions in cold air while producing hurricane-force wind, surge, and severe convection elsewhere. One set of fronts allowed both faces to exist within the same storm. Look once more at the satellite view. Its broad cloud shield was not evidence of a hurricane and a blizzard fused together. It traced contrasting sectors turning around one extratropical center. One side carried Gulf air north, the other drew winter south. That is how one storm behaved like a hurricane and a blizzard without ever becoming both.